thank you guys for being here today for this final talk by the BIC students. I would like to say that from now on, all the talk will be recorded, and these guys be now that the talks are going to be like high tech.
Hello everyone. The first project is done by Miguel and Marco. These two guys are amazing scientists. Now they are scientists. They were not earlier. Okay, they are amazing scientists. They are going to present a project, which of course they will present. But Miguel is from FEW and Marco is from ISEP. They two make a fantastic team and have done a great job in actually collecting data from a flying sensor node, which they will present right now.
Our project is called Sensing in Motion because our major goal is to sense environmental data, but not in a static way like the already existing ones. For example, these three examples of fixed stations. Our idea was to create an autonomous flight system capable of taking the environmental measures and then transmit the data in real time to a server in order that anyone can see what was collected in the moment.
Regarding the software on the quadcopter, we actually developed two different applications. One was for manual control, where a user can control the quadcopter manually, and an automatic application where the user can previously define a path on programs like ground control, and then initiate the mission with the program.
So this is the drone flying. Is sometimes it's not very stable.
Yeah, considering all the weight we're putting into.
Is it running on autonomous mode?
No,
Standard in manual.
yeah. During this test, we chose to do it manual because in the autonomous operation, we would get more of an unstable system, and actually the lifetime we got from all the weight we're pointing to was about 4 minutes and a half. So we chose to do it manually.
Without the sensors on top, the autonomous flight works really well, but with all the sensors, it doesn't work the same way. And in manual control, you can do little modifications, corrections over time. So this is the second place, the dirty one.
Yes, near the construction field. So as the battery decreases, we actually notice that he loses altitude, which is a big problem when putting this system on a real life situation, because in order to avoid the obstacles, would have to be at a higher altitude and probably be affected by wind, extreme wind when comparing to ground conditions. So that would be a problem. But that could only be fixed with a battery maybe that could carry all the weight we were putting on it.
Myself and Miguel learned a lot with this project. We didn't work with Arduino and this kind of stuff, so it was a very good opportunity for us. We have to say thanks to our cameraman, to Vikram for the help they did, and to all of our colleagues, all the persons from CISR that helped in some ways. For example, Pedro was a very good help, so thanks Pedro, and that's it. I hope you enjoyed it.
Most of you already know about this project. This was the idea was to build a video conferencing system that would support an improved interaction between a remote user and the meeting room or meeting space, by supporting movement inside a meeting room, trying to mimic as much as possible someone in a room. I'd like to point out the huge effort and the tremendous job that these guys did. They met almost pretty much all of the goals that we set beforehand, and they did a tremendous effort. I mean, these guys didn't have any vacations. At least Ron did not. And but more than the fact that they actually achieved what we asked them to, and they actually fulfilled those goals, I'm quite happy that they learned a lot. I believe that they actually grown as engineers by solving new challenges and facing new problems and actually solving them and adapting to new circumstances they had never been before, like hardware issues. Right? Thank you all and thank you for your effort. So I hope you enjoy the presentation. Okay.
I will start our final presentation. I want to thank you all for your attention. Thank you, Ricardo, for the introduction. So, I will start with a brief introduction. Majority of you already know this project, but for one or not, I will say that the idea behind our project is that we want to make a contribution in long-distance communication. We already know some ways, some means of doing this with video conferencing systems, and this in that specific field that we want to make a contribution. The already existence means are limited because they only allow the transmission of sound and image, and our contribution is to have also movements in that transmission of communication.
We divided our system in three subsystems. They are the remote user PC, our everyday PC that you use, the Raspberry Pi, the normal Raspberry Pi, and the Wi-Fi bot. It's relatively simple. We can move the camera around, and most important, we can move it. I think not. So if I run, so I can see it's a tricky situation.
We practice this path a lot.
The camera also moves, so if you are doing a presentation or something, you can see all the...
Arthur, you should use this to record videos in YouTube.
So basically, it's our project. I hope you like it. If you want to play it,
They are also being shot.
As all of the teams, Nuno and Dalila are also students from BIC and FEW. Nuno is from BIC, Dalila is from FEW. They started off with a lot of ambitious ideas. Even we took I think 1 or 2 weeks to even filter out their ideas and come up with satisfy their goals. And this is a project which I guess most of all you know about, but the main goal in the starting was to have image processing done by the drone and then help it to track the path of an image. So to make it more fun, we give it an idea of painting an image, so that involves capturing an image and then processing it. So Nuno and Dalila was in a lot of hard work because a lot of things like OpenCV required for image processing they didn't even know about. So I hope they learned all these things, and let's see what they have done.
Started this project on 18th May, and at the start we already were thinking about projects to do. We knew that we wanted to work with a quadcopter because it's fun. It has propellers and it kills people. It's pretty fun. So we had a lot of time to think about it. In 1 week we determined the project, the theme, and then almost to the end of June we started to selecting the materials we needed to create this quadcopter.
Basically, you have this camera here that is looking to the quadcopter, and the quadcopter has these two marks, yellow marks on it, that basically allow us to know where the quadcopter is, what distance from the wall it is, etc. And that's basically what's one of the things that was most difficult to do, because we had to recognize the quadcopter in the camera image, know where it was, and try to figure out the distance, rotation, etc.
Like, we have a casualty there, so Paulo is almost without an arm from handling this. Yeah, this is our interface. Yeah, it moves, and it's okay. It's not that. It moves. Okay. I'm using the Visual Studio on the back end, so it's easier to connect it. So I'm going to start by doing the manual controls. So because of the battery is really not that great, so we need a new battery. So it shouldn't have any problems here. I need to hold it. So as you see, it's not that stable. It's not that stable. It has some problems. The Arduino is not that powerful. The Bluetooth is really slow, and we still have another delay. So it can with this hardware we can stabilize it. It's way too hard. The delay that comes from the Arduino processing the data is really not good, and when it thinks that is over here, it's not over there. So, but these was manual controls. Now what happened is the wires were obviously interfering, so we won't kill anybody. And we need to figure out the weight position a little bit more and a little bit less. So this is the end of our little show. At least it moves. Yeah, it's always great. Thank you for watching.